Okay guys, here we are at area, and we are finding one exterior angle of a 42-agon. Well, exterior angles, they sum, no matter how many sides a shape has, to 360. So you're going to do 360 divided by 42, because that's how many sides, and, oh gosh, all my blanks went away here. Darn. 8.57 would be your answer. All right, find one measure of one interior angle of a 32-agon. Well, that's going to be n, the number of sides, minus 2, times 180, then divided by the number of sides, right? Because that will give us the total sum, and then each angle we'll figure out by dividing the sides. So 32, since it's a 32-agon, minus 2 times 180 divided by 32, the number of sides. All right, well, that's going to be 5,400 divided by 32, and that's going to let us know, again, another missing line, that it is 168.75. Okay, find the sum of interior angles of a 28-agon. So sum of interior angles, not just one anymore. So that's the more simplified version. 28 minus 2, and then times 180, which will give us 4,680. So 28 sides, all inside of that angle, all of those angles inside would be 4,680 degrees. All right, this is kind of a trick question. Find the sum of exterior angles of a 72-agon. Well, no matter how many angles or how many sides it has, the exterior angles will always sum to 360 degrees. Okay, next up, a tricky one here. Oops, sorry, I'm not making you dizzy by moving this around. Okay, if the sum of interior angles of a regular polygon is 2,340, how many sides does the polygon have? Okay, so we are going to take that formula, n minus 2 times 180, because that's the formula for finding the total amount of angles, or the total measure of degrees, the sum of the angles, and set it equal to 2,340. All right, I'm going to divide by 180 and divide by 180. I'm going to get n minus 2 equals 13, and add 2 and add 2 and get 15 sides. So the trick is here is knowing, hey, I know the sum of the angles. What formula gives me the sum? Okay, this one is a bit trickier. So if the measure of one interior angle, so not the sum anymore, one interior angle of a regular polygon is 165, how many sides does the polygon have? So same idea of the formula, n minus 2 times 180, but since it's one angle, we have to divide it by the number of sides. All right, and we know that one angle inside this figure is 165 degrees. So first thing I'm going to do is multiply both sides by n, and I'm going to end up with n minus 2 times 180 equals 165n. And then what I'm going to do, because I find it a bit more simple, is I'm going to distribute this 180. So I'm going to end up with 180n equals, minus 360, right? 180 times n is 180n. 180 times negative 2 is negative 360. And I'm going to bring down my 165n. Okay, so now I want to get my n's on one side. So I'm going to subtract 180n and subtract 180n. And I'll end up with negative 360 equals negative 15n. I'll divide by negative 15, and I'll divide by negative 15, and I'll get n equals 20. So 20 sides. And again, a disappearing line. Okay, so if the measure of one exterior angle of a regular polygon is 12, how many sides does the polygon have? So again, it's exterior angles, which we know is 360, right? We're just not sure how many sides it has. So we know that we take the number of sides and divide it by 360. That gives us our angle measure. But this time we know our angle measure. Oh, whoops, sorry, I did that backwards. We do 360 divided by n, and that gives us our sides. Or degrees. Sorry, I'm making a lot of videos right now. My brain's a little mushy. Okay, so what we're going to do is we are going to get n alone by multiplying both sides by n. These would cancel out. I'd have 360 equals 12n. I'd divide by 12 and divide by 12, and I would get n, or the number of sides, is equal to 30. All right, for number 30, find the area of the figure below. So I am going to go like this, and I'm going to have this figure right here, figure 1, and I'm going to have this figure right here, figure 2. All right, figure 1 I know is 12, and I need to figure out this length, which to do that, I'm going to do 13 minus 9, and I'm going to get 4. 13 is the whole thing. If I take away this bit, which is 9, I'm going to get 4. So in order to find the area, I'm going to do 12 times 4, and I'm going to get 48. All right, and then down here, I'm going to multiply 9 times 21, and I'm going to get 189. All right, the 21, and then this is 9. All right, I'm going to add them together. So 189 plus 48, and I'll get 237, not degrees, but an area of 237. Moving right along. This one, just remember, technically these are perpendicular, so it's just base times height, right? But your base and your height have to be perpendicular. So you need to do 12 times 8, which is going to give you 96 units squared. Okay, so let's remember that area is equal to the apothem times the perimeter divided by 2. So to find the area of a regular heptagon, the apothem is approximately 5.58 centimeters long, and each side is 14 centimeters. All right, heptagon is 7, so if we want to find the perimeter, we're going to do 7, the 7 sides, times each side, which is 14. We're going to get 98. All right, they gave us the apothem here, so to find the area, we're going to do 5.58 times 98 all divided by 2. So when you multiply these two, you should get 546.84 divided by 2, and you would have an area of 273.42. Okay, next up, 33. Remember, area of a triangle is base times height divided by 2. Keep in mind, guys, there's a lot of information here to confuse you, but this is your base and this is your height because they're perpendicular to each other. So you're going to do 25 times 14 divided by 2. 25 times 14 is 350. Divided by 2 is going to give you 175 units squared. Okay, leave an exact form. That means with pi, the symbol pi. Okay, so we know that it's a hexagon. That's 6 sides. All right, and then if we were, here, let me just draw a quick little hexagon. Okay, so we're going to find the central angle, which is going to be 360 divided by 6, which is going to give us 60 degrees. But keep in mind the apothem comes down and cuts that in half, right? So we technically have a triangle with 30 degrees because the apothem, this perpendicular line to the side, cut it in half. All right, the side length was originally equal to 8, but now it's going to be equal to 4, right? Because it was cut in half. So keep in mind across from the 30 of a special right triangle is n. All right, and this would be 60, and across from 60 is n rad 3. So we know that if n is equal to 4, this is equal to 4 rad 3. All right, remember to find the area with the apothem, that's going to be your perimeter, your apothem times your perimeter divided by 2. So we're going to take our apothem, which we know is 4 rad 3, times our perimeter. Well, our perimeter is going to be 6 times 8, which is 48. Each side is 8. There's 6 sides, so 48. And divide it by 2. Alright, so what's wrong here? Leave it exact form is with a radical. We're not to circles yet. So we're just going to leave it as 4 rad 3. We're going to multiply 4 times 48, which is going to be 192 rad 3 over 2. All right, we're going to divide these two because the radical is protected, and we're going to get 96 rad 3. All right, next up, find the area of the trapezoid shown below. Okay, so that's the area of a trapezoid is going to be base 1 plus base 2 times your height divided by 2. So we're going to take our two bases. Area is going to be equal to 13 plus 15 times our height, which remember it has to be perpendicular, so straight up and down, all divided by 2. We'll simplify. We'll get 13 plus 15 is 28. Multiply it by 10, divide by 2. 280 divided by 2 is equal to 140. So 140 units squared. Okay. We get to work backwards here. Find the height of a trapezoid given its bases measured 10 and 18, and the area is equal to 126. So we're going to plug in what we know. We know that the area is 126. We know that the two bases are 10 plus 18. What we're trying to find is the height. So my two bases times my height divided by 2 equal 126. First thing we want to get rid of is this 2. All right, that's going to be 252 equals, I'm just going to add those together, 28 times my height. All right, to get 28 alone, to get h alone, I'm going to divide by 28 and divide by 28. I'm going to get h equals 9. All right, and we're almost done here with this section. Find the area of a rhombus whose perimeter, so I'll draw a rhombus, is 40 centimeters. All right, so we know that all four sides are 40 centimeters together. 10 plus 10 plus 10 plus 10 equals 40. All right, and we know that one diagonal is equal to 8 centimeters. So I'm going to remember back that the diagonals bisect each other, so this whole thing is 8, but they cut each other in half, so it's 4 and 4. I'm also going to remember that the diagonals are perpendicular. So what I want to find is this segment, because the area of a rhombus is diagonal 1 times diagonal 2 divided by 2. And so far, I know that I have one diagonal that is 8. I need diagonal 2. So I'm hoping you guys can see that this is a right triangle. I'm going to redraw it to hopefully give you a better visual. All right, here's the 4. Here's what I'm solving for, and here's my 10. Okay, these are my two legs. So I'm going to do 4 squared plus x squared equals 10 squared. 16 plus x squared equals 100. X squared equals 84, right? When I subtract 16 and subtract 16, I take the square root and the square root, and I get x equals 9.17. All right, so what I'm going to do is sneeze. Let's go ahead and double it for the second diagonal. Diagonal 2 is going to be, since this is 9.17 and this is 9.17, right? The diagonals are bisected. The two diagonals, or the whole diagonal of diagonal 2 is going to be 18.34. All right, so now I'm going to multiply the two diagonals together. 8. So my area is going to be equal to 8 times 18.34 divided by 2, which will give me 73.36. Okay, and then this one is easy peasy lemon squeezy. We know one diagonal, diagonal 1, is equal to 10. We know our other diagonal, diagonal 2, is equal to 14. And we are going to multiply them and divide by 2. So 10 times 14 divided by 2 would give you 140 divided by 2. I'm missing line again. It would become 70 units squared. Okay, and the very last one I was wrong for this section is going to be find the area and circumference of a circle whose diameter is 24. So keep in mind, guys, that if this were our circle and we're going all the way across, it's 24, this would be 12, and this would be 12 for our radius. So our radius is equal to 12. Okay, So the first thing it wants us to find is area, which remember area is equal to pi r squared. Well, in this case, for area, our radius is 12, so we're going to do pi times 12 squared, which is 144 pi. Circumference is pretty straightforward. It's either pi times your diameter, which they gave us our diameter, right? Or it's 2 pi r. All right, well, I'm just going to do pi times my diameter. My diameter is 24 and pi. And when it says leave pi in the answer, it simply means don't multiply it by 3.14. Leave it exact, right, with the symbol pi. And that's it for that one.